Physics Lab 3, the black hole. We use this lab to generate the unique star trajectory, and based on the star trajectory, we analyzed motion to find our net force, and based on our net force, we calculated the mass of our unknown black hole. My results were that my black hole ended up being about 2.1 times 10 to the 34th, and this lab differs from previous labs due to the fact that we were beginning with our position and time data, which I will discuss further. We also were given the gravitational constant, the mass of our star, and the change in time. I then used Newton's second law as long as with fundamental principles to apply different principles to my code and to get my mass of my black hole. Here you see I used the momentum formula to get my momentum initial and momentum final, which I then put in my code below. Like I said earlier, this is different from previous labs because we are using this data right here, or this is how our code is actually set up to be finding the change in momentum over the change in time based on the given position data, based on Newton's second law. And then I used in step 1 the change in velocity and the change in momentum, implemented them into my code in step 1. In step 2, I am proving how our net force is equal to dp dt because it is the single force acting on our star, and this is also obtained from Newton's second law, also then implemented in my code below. And in step 3, I am calculating p hat from my initial momentum vector over the magnitude of my momentum. I'm calculating the magnitude p over dt from the initial magnitude and the final magnitude over time, and then I'm calculating dp over dt parallel by multiplying dp magnitude over dt times my p hat and implementing into that code on the right. Then like I said previously, our Fnet is equal to dp dt, so Fnet parallel is equal to dp dt parallel. Then I was taking dp dt and subtracting dp dt parallel to find dp dt perpendicular. And then, like previously stated, dp dt perpendicular will equal Fnet perpendicular, and all three of those things were implemented into my code on the right. On the other hand, I could have used p magnitude times v magnitude over r in a different situation. However, we had no way of finding the radius of our kissing circle, so this would prove ineffective. And I was able to get all of this data based on Newton's second law principles, which are shown in the bottom right of the simple equations in which I derived my 3 previous equations from. And overall, to find the mass of my black hole, I had my new Fnet, which is equal to, as Newton's second law says, gravitational constant times mass 1 times mass 2 over the magnitude of r squared. I then rearranged this formula to solve for my mass 2, which is the mass of my black hole, and implemented that into my code on the right. And then I added in my aeroscale to find my arrow lengths, and the arrow scale must be very tiny since we are using such a large scale when referring to our star, black hole, and the gravitational pull. I used the 3 different forces calculated, Fnet, Fnet perpendicular, and Fnet parallel, multiplied them by my arrow scale, and that's the way I got my arrows for the final images coming up next. I have now my final images here. As in the left upper corner, I have the final total trajectory of my star and forces with the black hole constant. In the middle image, I have the zoomed in image of my arrows. The small one in the circle is my Fnet parallel, which is blue. It is so tiny because our time is hardly changing over each step. The orange arrow is my Fnet because it is pointing towards our single force acting on it, which is the black hole. The pink arrow is my Fnet perpendicular because it is pointing in towards the center of said kissing circle for my star. And below I have my Fnet, Fnet parallel, Fnet perpendicular, all calculated out. And then the mass of my black hole, as stated previously, is about 2.1 times 10 to the 34th. What does this mean? We are able to see how the rate of change in its momentum is actually going to end up being the same as Fnet and its components because they're equal to each other based on Newton's second law, which is how I was able to do the calculations for this lab. And if we put a different black hole in the place of our new black hole, you actually should be able to get a different mass because in our force equation, as previously stated, G times mm over r magnitude square, it will end up having an effect with a different m in place, and therefore you calculate the new mass with row script, and that is the end of this lab.